Question 8. A sample consists of 2 grams. So the mass is 2 gram radioactive element. The molar mass is given as 67 gram. If the half-life of the element is 78 hours, calculate the activity of the sample after 30 hours. Okay, so for this one, we are going to use A equal to A naught E negative lambda T. So from here, what do we do not have? We do not have the value of initial activity. We do not have the value of decay constant. Okay, so firstly, we are going to try to solve for the initial activity. So we know that the initial activity can be calculated using lambda times with the initial number of molecules. And lambda, which is the decay constant, is equal to ln 2 divided by the half-life. Okay, so first let me just calculate this. It will be so this one 78 times 60 times 60. Okay, that is 78 times 3600 is 280800. 800. Yeah, so this is in seconds. So just substitute that into here and you will get the decay constant to be equal to something. Okay, they did not calculate it. I'm just gonna calculate it here. So it's gonna be 2.468. You can either take 2 decimal points or 3 decimal points. It's gonna be 10 to the power of negative 6. So this is in seconds, so per second. Okay, so we have the decay constant. Now we have to find the initial number of molecules. So that is gonna be mass divided by the molar mass times with the Avogadro's constant. Okay, so this one is, both are in grams, so we don't have to convert that. This is 6.02, then 23. This is gonna be equal to 1.8 times 10 to the power of 22 molecules. Okay, so we have the decay constant and the initial number of molecules. We just have to substitute this number here and you will get the initial activity to be equal to 3.4 times 10 to the power wrong, sorry, it's gonna be 4.4 times 10 to the power of 16 becquerel. Okay, so that is the initial activity. We can then find the activity after 30 hours because we already have all the values. So this is 4.4 times 10 to the power of 16 E negative lambda is 2.468, 10 negative 6, and then T is 30 hours. So we do have to convert that into, did I mention ka diminta apa? Oh, we do have to convert that into seconds because becquerel is decays per second. And you should get, let me just quickly calculate it because I'm not sure if I'm doing it correctly, but I think I am. Negative 6, 30, 60, 60. So you will get 3.37 times 10 to the power of 16 becquerel. Okay, all right, so that is how you solve question number 8.